A 6-inch class 1500 designation may look complete on a purchase request, yet it leaves several decisions unresolved. If pressure temperature limits, materials, connections, process conditions, and acceptance requirements are unclear, the result can be an unsuitable valve, installation rework, or an indefensible acceptance baseline. Specification should begin with the duty. Define the fluid, normal and maximum pressure, normal and maximum temperature, anticipated flow range, flow direction, solids, corrosive constituents, and operating sequence. Include startup, shutdown, temperature cycling, pulsation, pressure excursions, and external exposure where relevant. The valve must permit intended flow, then close and seal as reverse flow begins under those actual conditions. The closing event also deserves attention. On pump discharge or in systems with changing demand, flow decay can interact with valve closure and pressure transients. The engineer may need to evaluate surge, closure speed, minimum differential pressure, or an alternative check valve geometry. A swing design should be justified against system behavior, not selected from its name alone. Next, establish the pressure temperature basis. Class 1500 is a selection input, not a fixed pressure limit independent of temperature and material. The final datasheet must identify the governing standard and show that the rating applies to the actual pressure-retaining material, end connection, and design conditions. Listed references such as API 6D, ASME B16, 34, BS 1868, ASME B16, 10, ASME B16, 5, ANSI B16, 47, and API 598 cannot simply be treated as universally applicable. Their role must be confirmed for the supplied configuration. Materials must be reviewed as a complete system. Carbon steel, stainless steel, alloy steel, and low-temperature steel options, including WCB, CF8, WC6, and LCB, are starting points rather than automatic approvals. Examine the body, seat, disc, bonnet, hinge, pin, gasket, studs, and nuts together. Consider corrosion, toughness, wear, temperature, welding requirements, and client material rules. Define which components require heat number traceability, test reports, positive material identification, heat treatment records, or third-party verification. Connection selection affects both installation and lifecycle cost. Flanged ends can support removal when bolting and lifting access are available. But weld ends may suit a permanent piping arrangement, but replacement can require cutting, welding, non-destructive examination, and a controlled outage. Confirm facing, drilling, gasket approach, mating materials, weld end preparation, connected pipe schedule, face-to-face dimensions, orientation, flow arrow, support, insulation, lifting points, and maintenance clearance. Obtain the final dimensional drawing before spool fabrication or purchase release. Testing converts a described valve into an accepted asset. The inspection and test plan should define shell and seat tests, dimensional checks, material document review, visual inspection, acceptance criteria, witness points, records, and review responsibilities. Broad statements of compliance are not equivalent to configuration-specific evidence. During bid evaluation, record each supplier response as confirmed, conditional, or unresolved, and cite its supporting document. Critical gaps involving process duty, rating, materials, or testing must be closed before release. Any remaining open item needs an owner, due date, approval route, and hold point preventing premature manufacture. Finally, preserve the approved datasheet, drawings, material certificates, test results, deviations, receipt inspection, repair history, and spare identifiers with the asset record. This evidence gives maintenance teams a reliable baseline when leakage, noise, abnormal differential pressure, or reverse flow behavior changes. The sound procurement decision is therefore not merely a valve size and class. It is a verified configuration supported from initial duty definition through installation, acceptance, and eventual replacement.